Welcome to Techstination. Joining us are Dr. Michael Recht, Chair of the Department of Radiology at NYU Langone Health, and Nafisa Yakubova with Facebook's Artificial Intelligence team. Thank you for joining us, Dr. Recht and Nafisa.
Hi, it's great to be here.
Thank you, Fred.
What we're talking about is a breakthrough that you're announcing today about the use of artificial intelligence in MRI scans. I'll let you start out telling us a little bit about it. I suppose Dr. Recht first?
Sure. We're really excited because what we've been trying to do is find a way to make MRs faster. I don't know if you've ever had an MR, but if you've had, you know that you need to lie still. And the exam can take anywhere from 20 to 30 minutes to well over an hour. And it's hard to lie still. And it's uncomfortable. And because it takes so long, sometimes it's hard to schedule. You have to wait for a while before you get the appointment, and it gets to be really expensive. And our goal was to change all of that, was to allow us to go much faster, getting the exact same information, making the same diagnosis. And, in this study, we were able to accelerate imaging by a factor of 4, which meant that we could go 4 times faster. Making exams, our goal is to really make the exam only about 5 minutes for, in this case, a knee exam. And we think that's really, really very exciting.
Tell us about the use of artificial intelligence here and Facebook's involvement in this.
Yes, so I can tell about that. Facebook AI research team is a part of Facebook, maybe lesser known than the main part that focuses on Facebook products. So as Facebook AI research team, we solve scientific problems in the field of artificial intelligence. So it's, if you will, it's more like academic style research department, where for this specific project, we were looking to solve challenging AI problems at the same time having an impact in the real world in people's lives. So, for example, if you have seen maybe in the news before, like how AI can generate realistic images of celebrity faces, right, or other images. So we started to think, like, what are the good use cases we can put it into? And one of the is medical imaging, which is inherently a computer vision problem, but the bar is quite high there, right? You have to get medical imaging perfectly right. You cannot add something that's not supposed to be there or remove something. So it creates a very interesting, challenging problem. And that's why we teamed up with NYU to solve this problem together with the domain experts and make sure that AI models and solutions are tailored to the needs of the medical community as well.
Dr. Recht, you mentioned costs involved with the fast MRIs, et cetera. Does this add to the expense, though, having to put in the equipment to be able to use this artificial intelligence?
Yeah, that's really a great question, and the answer is no. What's great about this study and this technique is you don't need any new equipment at all. So the MR machine is the same, the computers that you use to reconstruct the images are the same. This is purely a software change. And because MRs go faster, we anticipate that the cost of MR will be decreased. Because right now, you have to, can only do a certain number of MRs each day, and the MR machine costs a certain amount, so it has to be a certain charge. If we can do 4 times, 5 times, 6 times the number of MRs in the same amount of time, the cost of the MR will come down. So that's why we think it's really exciting. The other really exciting thing about this is that, it should enable us to use MR for areas that we don't use them now. For example, patients who come in and are having an acute stroke. Recently, there have been a number of new developments that we can intervene and try to limit or stop the damage from the stroke. It would be great to use an MR to image the patient when they come in to see if, in fact, intervention is appropriate. But right now, we use CAT scans or CT scans because they're faster. Now, they're good, but remember, they have radiation. The nice thing about MR is there's no radiation at all. So if we can make MR faster, MR could replace CT scans in that indication. So it increases the breadth of what you can use MR for.
Interesting. And the results that you're getting are at least as good as what you've had until now? The accuracy?
Yeah. So the study that we're announcing, we looked at 108 knees, looking for tears of the menisci or the ligaments like anterior cruciate ligament tears or bone abnormalities. And we looked for two things in the study. The first was the sequence that was accelerated had to be equally as good as our standard sequence about picking up abnormalities and making the correct diagnosis. And what we found is the two sequences were completely interchangeable. We had 6 experienced radiologists who do nothing but look at bone and joints. And they all showed that the images were indistinguishable. It didn't matter whether they looked at the accelerated sequence or the standard sequence. But the other part of this experiment is every time we've accelerated in the past, what we've seen is the images that we get don't look as good as the normal images, right? They can be a little bit less sharp, a little blurrier. And part of the study was to say, could these images look as good? And we were hoping that people would say, yes, they look as good or almost as good. What was incredibly surprising but very exciting was that all 6 radiologists said that the accelerated images looked better than the clinical images. And that was something that was unexpected but really exciting. We asked each of those radiologists when they looked at the images to see if they could tell if they were looking at the accelerated or the clinical images. And except for one, 5 out of the 6 were no better than flipping a coin. And that really gave us great confidence that if this study's results are validated at larger studies, that we can translate this technique into routine clinical practice very quickly.
And how quickly can this be rolled out broadly, this technology?
Yeah, that's also a great question. What's really unique about this research is when we went into this and this collaboration with Facebook, we decided that everything we did was going to be public. It was going to be publicly sourced. There would be no intellectual property. And the reason for that is we wanted to get this out to really help patients as fast as we could. So we've been working with all of the major vendors. We've made public all of our data sets. We've made public the model that we used in this study. And all of the major vendors are already looking and integrating this into the machines. Now, we still have to do larger studies, and then we still need to get regulatory approval, and that will probably take, somewhere between maybe 18 months and 24 months, which might seem like a long time, but medical imaging is really very, very quickly. But we're really enthusiastic and optimistic that within that short time period, this really will become a standard way of imaging when you get an MR examination.
Nafisa, I don't know if it's applicable here, but I know with artificial intelligence, there's something called neural networks where it can learn, get better over time. Are we going to see that? Is this going to be better and better as you go along?
Yes, so we are using neural network to train models for reconstructing MRI images. So the way we developed the neural network is we incorporated a lot of MRI domain knowledge, medical imaging domain knowledge, so that neural network performs better. So it's not blindly reconstructing an MRI image of the knee or the brain, but it has learned and it's been learning a lot about how MRIs work in the first place. So yes, it is. That's why it's part of the AI research that you're teaching the models to learn better. And we are hoping that because this is open project, open scientific project, that other groups, other researchers, other medical community members could also use this to develop further solutions, tailored to new cases, in order to make MRIs more accessible around the world.
Terrific. Well, we congratulate you on the work that you're doing there, and thank you for it. Dr. Michael Recht and Nafisa Yakubova, thank you so much for taking the time with us.
Thank you.
Now this. How many companies out there have continued to innovate when it comes to building a better radio? I'm Fred Fishkin, host of Techstination, and I'm here to tell you about the new CC Skywave SSB radio from the wonderful people at C. Crane. Bob and his crew really love radio, and it shows in this new compact model that is packed with features. Beyond great AM and FM reception and sound, you can tune into shortwave signals from around the world. Listen to ham radio operators, aviation, and more. It's the radio you'll turn to every day, and in emergencies. It will run for nearly 3 days on just 2 AA batteries. Pair the sleep timer with the new Soft Speaker 3, and you've got the perfect radio for your nightstand. Of course, it can wake you up too. Click on Crane at Techstination.com and put in the code Techstination for a free flashlight with your order. They love radio, and you'll love C. Crane.